टेढ़ा दिखता है ना थोड़ा सा. Good morning, my students of 10th class. Here is the next session for the chapter magnetic effect of electric current, and in that we are going to learn force acting on a current carrying conductor in a magnetic field. I have already taught you about the force acting on a charge moving in a magnetic field. And what is the magnitude of the force we have already calculated in previous class. Here we are going to learn the force due to magnetic field on a current carrying conductor. What is the magnitude of the force and what is the direction of the force? We will calculate the magnitude on the board, but the direction of the force acting on the current carrying conductor is known by the Fleming left hand rule. Recall the law which I have taught very well in previous class, the Fleming left hand rule. And the rule says that if we stretch the three fingers, thumb, whole finger and middle finger in such a way that each finger is perpendicular to each other, then and the forefinger indicates the direction of the magnetic field. The middle finger shows the direction of the current, then the thumb indicates the direction of the force acting on the current carrying conductor. Yes, my students, this is the Fleming left hand rule. Again, I am repeating. If we stretch the three fingers of left hand, that are whole finger, thumb, and middle finger, in such a way that all are perpendicular to each other. See here, this thumb is perpendicular on forefinger and the middle finger. Like this forefinger is perpendicular on thumb and the middle finger, and the middle finger is perpendicular on this horizontal plane because the thumb and the forefinger is in horizontal plane and the middle finger is vertical, so it is perpendicular on the both. In this way, if we stretch the fingers of the left hand and if the forefinger indicates the direction of the current, in which direction? No. The forefinger shows the magnetic field lines, direction of the magnetic field lines, and this middle finger shows the direction of the current. Then the force exerted by the magnetic field is in the direction of the thumb. In the direction of the thumb, the conductor moves or attracts any repel or attracted, it may be possible, but the force acts in the direction of the thumb. And now we want to know about the force acting on a current carrying conductor in a magnetic field. For this, we take a horseshoe magnet. Just, I have here a horseshoe magnet. Yes, definitely I have. Just I am exhibiting you the horseshoe magnet. Yes, my students, you have, it is a horseshoe magnet. Okay, my students, if you take it in this way, then the magnetic field the direction of the magnetic field is vertical. This is North Pole this is North Pole because here is a white spot on the magnet. So it is North Pole and the another end is South Pole. You are taking in this way the horseshoe magnet. Then the magnetic field is vertical. The magnetic field coming out from the North Pole and goes to South Pole. And here at the pole, they are parallel to each other. The magnetic field is vertical and a current carrying conductor is here. It is horizontal. Okay, my students? And if the current is flowing in the direction of this direction, from here to here, then you have to find the force acting on this conductor. How you can find? I will try my best to show you. 1 minute, excuse. Vicky sir. Vicky sir, please, there are time. If you दिखता है, देखिए तो वीडियो आ रहा है कैमरा में स्क्रीन पर यहाँ तक ये ठीक आ रहा ना? Yes, my students. Now see, this is a horseshoe magnet. The north pole is in upper part and the south pole is in bottom. Magnetic fields are vertical. Definitely. The magnetic fields are vertical in this shape and a conductor is here. This is a conductor in which current is flowing from in this direction to in this direction. Now, from Fleming left hand rule, what happens? See it, magnetic field, a forefinger is in the direction of the magnetic field. See it, the forefinger is in the direction of the magnetic field and this middle finger is in the direction of the current. Then thumb is indicating that this conductor goes inside the magnet. When current is flowing from here to here, then according to the Fleming left hand rule, the thumb indicates that the conductor goes inside the magnet. And if current is flowing in this direction, like this, current is moving in this direction and magnetic field is vertical, then the thumb indicates that this go away from the magnet. Well, my students, I think that it is very clear for you that what happens in a magnetic field when a current carrying conductor is there. It means in this device, the current is flowing from in this direction, then and magnetic field is this. Current is in this direction and magnetic field is vertical, then the thumb is saying that the conductor goes inside the magnet. And if current is in this direction, then and magnetic field is vertical, then the conductor goes away from this magnet. I think that it is clear. Now we will going to calculate the strength of the magnetic force exerted on the conductor, current carrying conductor. Vicky sir, please help me. Yes, my students, I think that it is clear what is the direction of the magnetic field. A force exerted by the magnetic field on a current carrying conductor, and this is found with the help of the Fleming left hand rule. Okay, now what is the strength of the magnetic force due to a magnetic field on a current carrying conductor? The factors on which the magnetic force depends. Magnitude, of force acting on current carrying conductor. First, magnitude of the current flowing through the conductor. First, on current magnitude. The strength of the force exerted by the magnetic field depends on the magnitude of the current passing through the conductor. Means, if the current is greater, then the force is greater, and current is little, then the force is also little. If 1 ampere current is passing and in another conductor 5 ampere current is passing, then on 5 ampere current the force is greater in respect of 1 ampere current. It means the force is directly proportional to the current passing through the conductor. If is directly proportional to the I. Okay, my students, next, magnitude of magnetic strength. The strength that is B. If the magnet is strong, it means magnetic field is strong, it means magnetic strength is strong, and then the force is a stronger force act on a current carrying conductor. So the force is directly proportional to the B. Second factor on which the force acting on a conductor depends. The third, on the weight of the conductor. Magnitude of length. Magnitude of length of the conductor. It means if a simple 1 inch wire in the magnetic field, then the force is less, definitely. And when the wire of 1 meter, the force acting on that wire is greater. So F is directly proportional to the L of the conductor. And the last angle between the current carrying conductor and magnetic field. Angle between angle between current carrying conductor F is directly proportional to the sine theta. The angle between the magnetic field and the conductor. It means if theta is 90 degree, then sine theta is 1. 90 degree is equal to 1. Therefore, the strength is maximum. According to Fleming left-hand rule, also it is true. All three are perpendicular to each other. It means they are making 90-degree angle with each other. So the strength of force is maximum when the angle between the magnetic field and the current carrying conductor is 9. Means the direction of the current carrying conductor is 90 degree. The Fleming left-hand rule explains it. Combining the all, we get a formula that I am erasing it. F is yes. Final F is directly proportional to the IDL sine theta. And here if theta is 90 degree, then sine theta sine 90 degree is equal to 1 and the force is maximum. If you eliminate the proportional sign, then F is equal to K into I B L sine theta. And the value of K is 1. If 1 ampere current is passing, the strength is 1 Tesla and the length of the wire is 1 meter and the angle is 90 degree, then the K is equal to 1. Therefore, F is equal to I into B into L sine theta, and theta is 90 degrees, then the force is maximum. I B L sine 90 degree is equal to 1. This is the formula to find the strength of the force acting on a current carrying conductor when the current carrying conductor and magnetic field is making 90 degree angle between both. Now we are going to learn the application of the magnetic field effect. A marvelous thing is that Earth is himself a magnet. It is a very heavy magnet, and magnetic field all around the Earth's surface is active. And this magnetic field protects the human from the radiation of the sun. What a miracle is occurring in the universe, and that Almighty God is how much a greater scientist who have made plants such way that he had given the earth a magnetic property, and due to that, a human being is protected from the sun radiation. But it is very bad to hear that the magnetic strength of the earth is decreasing in Africa and South America. The magnetic strength is lesser and it is very dangerous for the human being. And also a new thing I am putting you that in millions of years, near about 7 to in such years, the pole of the earth is changed. The North Pole is converted into South Pole, and South Pole is converted into North Pole. It may be visible in this Satabdi, the pole of the earth is changed. It may be possible as scientists think, but it is a news for you that if it is North Pole and this is South Pole, it means this is South direction and it is North direction. There is geometrical direction. Because when you hang a magnet, then the South Pole comes in this direction, so it is a South direction, and the North Pole comes in this direction, so it is North, geometrical North direction. But pole of the earth, here is North and here is South. And after such millions of years, the pole are changed and a new creation occurs, and this thing becomes South Pole and this becomes North Pole of the earth. It is miracle is done by the nature. And a miracle is also going on that the magnetic field at the Africa and the South America, the magnetic field of the earth is decreasing. And also the magnetic effect of magnetic field. A region of Earth's magnetic field which trap the charged particle coming from the sun. These belts were discovered by Explorer 1 in 1958, and this belt is called Van Allen radiation belt. A new information for you. Van Allen radiation belt is an area which is discovered by Explorer 1 in 1958, a region of the earth where magnetic field which trap the charged particle coming in the radiation of the sun. So the magnetic field of Earth is how much necessary for human life. You think about this, my children, and I request that why you are destroying your Earth by doing so many wrong activities in your life. So I request that save your Earth by doing a correct activities in your life. If not, then one day come when the magnetic field decreases up to zero and you will die with the help of sun, who is giving you energy. In opposite, due to the radiation particles, you will be dead at the earth. So please save the earth by making some good jobs for the earth. It is so essential, the magnetic field of the earth, for the human life. My students, that is the end of the effect of magnetic force on a current carrying conductor. And as per my knowledge, I have given you some new information. I discussed about a new belt called Van Allen radiation belt, which exists on the Earth, an area of magnetic field of the Earth where the magnetic field traps the radiation of the sun, radiated particles of the sun. Students, and next day we will learn the uses of the Fleming left hand rule in some electrical component, electrical device, and that devices are motor and generator, and in both Fleming left hand rule and Fleming right hand rule are used. So again I am requesting, please learn your book, study your book, and then you see my video. I think that your lesson will be clear. Thanks. God bless you. Make a nice day. This is the last time of the lockdown, so be careful. The number of corona is increasing in our district, so be careful, please, my students. Thank you.